Hi, my name is Chloe Lee and I'm in AP Calculus AB Mods 19 to 21 and this is my arc length project. The path that I decided to choose was the path I run on in my town. The path is located in Closter, New Jersey and starts at Alpine Drive, goes to Anderson Road, Hickory Lane, Piermont Road, and ends back at Alpine Drive. I wanted to see how much I ran, and to calculate this, I used the perimeter of the polygon as well as the arc length formula to calculate the length of the polygon mapped. For the measurements of the path, I first divided the path into separate points, which included O, A', A, B, C, D, E, F, F', G, H, I, J, K, and L, as seen on the map. I then divided the points into separate parts and measured the distances from the map from one point to the other. So these parts included O to A, from point F to G, G to H, H to J, J to K, K to L, and L to O. I then had to use the arc length formula to measure from A to C and C to F. The distances for each parts mentioned previously were measured from the map using the Measuring Distances and Areas tool. The distances in feet are shown below. O to A was 800 feet, F to G was 660 feet, G to H was 1,800.48 feet, H to I was 316.8 feet, I to J was 422.4 feet, J to K was 2,323.2 feet, K to L was 475.2 feet, and L to O was 1,056 feet. To determine the coordinates for my curve, I first measured from one endpoint of the curve, the origin, to another to create a positive x-axis, and then set the origin to be at the beginning point of the curve at the intersection of Piermont Road and Alpine Drive. The x values were found by measuring distance from the origin to the desired point, and the y values were found by measuring up to the curve from the certain x value. The coordinates from B to F are shown in the map to the right and will later be used to create a curve. The coordinates for arc 1, which goes from points A to C, are shown in the table below and in the map to the right. From A to C, I tried to find the distance using higher degree polynomials, but this led to overshooting and the quadratic gave me a curved rather than flat graph. I then included an auxiliary point, A', and used a cubic regression instead. I then used cubic regression to find f of x, and then used f of x to find f' of x. With f' of x, I then was able to use the arc length formula, which is shown above. I plugged in f' of x into the arc length formula and got that my arc length was 494.184 feet. I then did the same thing for arc 2, which goes from point C to F, and the coordinates of these points are shown in the table as well as the map to the right. From point C to F, I used the same method that I used for arc 1. I included an auxiliary point f' and used quartic regression. Using quartic regression, I was able to find f of x and then f' of x. Then I was able to use the arc length formula shown above and f' of x to find the length of the arc, which was calculated to be 2,302.62 feet. I then calculated the total distance of the path by adding the distances measured from the map and the arc lengths. The total distance was calculated to be 10,650.884 feet, or 2.017 miles. So the total distance I run is 2.017 miles.